Now, how do you measure the correlation? Do you have anything such? Because we measure the length, we measure the weight, we measure area, we measure the pressure, we measure the force, we measure the temperature. So we need to have a measurement to measure the correlation, correct? Yes, that's what we call it as correlation coefficient. So correlation coefficient give you the measure of the strength of the linear relationship between two variables. So the correlation coefficient is nothing but it gives the measure of the strength of the linear relationship between two continuous variables in this case. So the letter R denotes the value. R denotes the value and it ranges between -1 and +1. So in the first case, if R less than, if R greater than, R is our coefficient, correlation coefficient, we call it as a correlation coefficient. If R is greater than 0, it implies a positive correlation. If R is lesser than 0, it implies a negative correlation. If R is equal to 0, it implies no correlation. That's what. If R is greater than 0, positive correlation. If R is less than 0, negative correlation. And if R is equal to 0, it's no correlation. So calculating the correlation coefficient takes time. Therefore, data is entered into, we can use the data can be entered into the various programming languages such as R, Python, and you can use that. You can use the programming languages to compute the correlation coefficient. It is one step. It's a single step to compute a correlation coefficient using programming languages such as R or Python. So now let's see what all types of correlation coefficients we have. There are mainly two types of correlation coefficient. The first one is Pearson's product moment correlation, and this is widely used correlation coefficient. So the Pearson correlation coefficient is defined in statistics as the measurement as the measurement of the strength of the relationship between two variables and their association. It's denoted by R. Again, I'm repeating the Pearson's product moment correlation. The Pearson correlation coefficient is defined in statistics as the measurement of the strength of the relationship between two variables and their association. And the correlation coefficient can be calculated using this formula, and we denote this as R, and then the product of xi. We will have two variables because we want to know uh, the correlation between the two variables. So what we will do is we will do the deviation, a sum of products of deviations of both x and y variable. So summation of product of deviations of x and y variable data divided by squares of summations of squares of sum of squares of product of deviations of x and y variables will the give you the Pearson's correlation coefficient. Just take these two components separately and do the division, and we'll get the Pearson's product moment correlation coefficient. So in this, R is coefficient of correlation, and x bar is the mean of x variable, and y bar is the mean of y variable, and xi, yi samples of variable x comma y. We can simply call it as a samples of variable x comma y, or you can say individual records or individual values of x and y variable. It's simply, if you put it in simple way, it's called a deviation. We have used that word deviation when we have calculated variance. And the second one that we have here is Spearman's rank correlation. So Spearman's rank correlation measures the strength and direction of association between two ranked variables. It basically gives the measure of monotonicity of the relationship between two variables. That's how well the relationship between two variables could be represented using monotonic function. So this is what the formula that we use to calculate Spearman's rank correlation, and it's denoted with the rho, the symbol rho. So rho here means Spearman rank correlation, and the d under di difference between the ranks of corresponding variables, and then n is number of observations. So here what we do here is, we measure the strength, and direction of association between two ranked variables. It's based on the ranks. So that is the reason we will take the difference between the ranks of corresponding variables. Okay, rho is equals to 1 minus of 6 sigma of di square. So you will take the rank at different individual values, x rank and y rank at different records. If you have 50 records, 50 records of 50 entities, so then you will calculate for the each record first d1 all square. Thus d1 is difference between the ranks of corresponding variable. That's d1 is equals to y rank y1 minus x1. So rank of y and then rank of x, and d2 is equals to y2 minus x2. d3 is equals to y3 minus x3, and n is the number of total observations of that. So that's called a Spearman's rank correlation. So these are the two types of correlation coefficients which are widely used. One is Pearson's product moment correlation. Second one is Spearman's rank correlation. Now let's get into the action. Let's do some calculations. A simple correlation calculation. Let's do measures of association. First one is correlation. So let's import pandas as usual. Import pandas as pd. Once the pandas is imported with the alias name pd, now it's time to create a sample data set. So let's create a sample data set. So data is equal to a dictionary x, this is x variable, and a list of 1 comma 2 comma 3 comma 4 comma 5, and on other side another key value pair and y variable. This time y variable, this is 5, completely opposite way, 5 4 3 2 1. It's pretty clear. So x is increasing and y is reducing. It's inversely proportional, which is negatively correlated. With that only we can tell, but just for fun, no issue. So then df, let me make it dfc is equal to, convert that dictionary into data frame, and data. So dfc, this is your data. You got the x and you got the y. So you got the two variables, that's x and y. Now let's calculate the correlation between X and Y. So let's calculate correlation between the X and Y. Okay, so correlation is equal to DFC of X dot simple correl. It's core. That's what the formula we're gonna use, and open. Yes, you got the core here, core, and DFC, and it's Y. And that's it. Correlation has been calculated. Now let's print the correlation. So correlation between X and Y variables are correlation, and it's minus 0.999999999. So if you round it off, it's -1. It's exactly -1. So they're clearly negatively correlated. So R is -1. You got the R -1 or minus 0.99. So this is negative correlation. So now let's do the positive correlation. Let me check the data exactly with the minor changes. Let me increase this. Let me make it this time 2, 4, 6, and 8, and this is 10. And let's see how it behaves. Rest all remain same. So this is DFC1 correlation. Again, I'm gonna use DFC, yeah, DFC1, and this is positive, absolutely positive. And here you can see that correlation is 0.999. Now you can take it up 0.99. It's if you round it off, you'll get the 1. So 1 is the positive correlation that you can see. If X increasing by 1 unit and Y is also increasing, so X increased by 1 unit, Y increased by 2 unit, X increased by 1 unit, Y increased by 2 unit again. So 2 plus 4 plus 6, and 2 units. Here it's increased by 1 unit. So there is a clear cut positive relation between X and Y variable. Now let's take one more example. This time I'm gonna put it X, Y. I'll go with the 0, and this one I'll put -5. This is 100, and this is 911, and rest remains same. It's 0.01. Again, if you round it off, 0.01, it's very small, and the values were closer to the 0. So with this, you can say there is no specific correlation between the variable X and Y. So this is how you can find out the relationship between two different variables X and Y using Pearson product moment correlation coefficient.